name is Arya Safaipur. Welcome to our second video. This video is about functional programming for scientific computing. I hope you will enjoy it. So let's begin. Functional programming for scientific computing. Discover how functional programming is revolutionary data analysis and modeling, exploring its benefits, its encoding, readability, and performance. This presentation covers key advantages, historical content, and practical applications in scientific computing. So in next slide, we will have a brief explanation about what is a functional programming and what is the key concepts of it. So we have the declaration style, focus on what to compute, not how to achieve it or how to do it. Then we have immutable data, which is data cannot be changed, leading to easier debugging or preventing from any bugging or problem to happen. Then we have pure functions. Output depends on the input. There is no side effects, only the input will create the output. And we have the first class functions, which these functions are treated as values and variables, and they will be passed like data. So in the next slide, we have the historical content. We have Lambda calculus, which was originated in Alonzo Church's work from 1930s. Then we have Lisp emerges. John McCarthy's developed Lisp in 1958, an early functional programming language. Then we have ML family. In 90s saw ML bring strong typing and pattern matching. Then we have Haskell's influence. Haskell 1990 introduced pure lazy evaluation principles. In the next slide, we have advantages in scientific computing. Parallelizations, inheritance concurrency due to immutability. Monte Carlo simulates benefits greatly. Then we have compatibility. Build complex operations from simple functions, data pipelines using map, filter, reduce, and there are some examples for it. Testability, we have pure functions are easy to test because of the numeric aggregations. Functions are ideal for this. Then we have the key functional languages. We have Python with libraries such as NumPy, SciPy, Pandas. All of them supports functional programming. Then we have Haskell, known for formal verification and complex algorithms. It's excellent for type-safe numerical methods. Then we have Julia, designed for high-performance scientific computing. Multiple dispatch enables generic algorithms. In the next slide, we have the case study data analysis pipeline. Sensor data ingests, review raw sensor data streams. Then next step is data cleaning, filter out noise and enormous entries. Then we have data transformations, apply function to reshapes data, and analysis and visualizations, extracts insight and expect findings. Functional programming enhances data analysis pipeline. It uses immutable data and compound function. This simplifies cleaning, transforming, and analyzing sensor data efficiently, avoid multiple states complications. Then we have case study numerical situations like define particle probability, particle properties, apply interrogations rules, map to parallel cores, reduce results. Then we have the performance benchmarks, so we could see how much the performance has been improved. So we have 2 times faster Haskell vectors. Haskell's data that we vector outperformed C arrays. 95% improved efficiency. Stream fusion boosts data processing speed. And we have 30% optimized operations, such as deformation techniques reduce intermediate structures. Functional programming can significantly outperform imperative code. Optimization techniques like fusion or deprecations contribute to this. This leads to efficient data processing and high-speed computations. In the next slide, you have the challenges and consideration which we should consider about this really hard. The library ecosystems less mature compared to imperative language. We have performance overhead, sometimes slower for very simple trivial tasks. Then we have learning curve. Different paradigm requires mindsets shift. And in the conclusion, the future of scientific computing, we have the growing traction. Functional programming is increasing in data science. Evolving ecosystems, tools and libraries are continually improving, and we have embrace functional programming for reliable, scalable, and maintenance code. Thanks for the watching. Looking forward for you to in the third video.